Electric Avenue. We're gonna rock down to Electric Avenue, and then we'll take it higher. We're gonna rock, 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 rock. We're gonna rock, 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 rock. We're gonna rock down to rock, 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 rock. We're gonna rock, 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 and then we'll take it higher. Electric Avenue. We're gonna rock down to Electric Avenue. We're gonna rock down to Electric Avenue. We're gonna rock down to Electric Avenue, and then we'll take it higher. Working so hard like a soldier. Can't afford a thing on TV. Working so hard like a soldier.
Everything we see is made up of tiny little parts called atoms. The atoms are made of even smaller parts called protons, electrons, and neutrons. They have different charges. Protons have a positive charge. Electrons have a negative charge, and neutrons have no charge. Usually, atoms have the same number of electrons and protons. Then the atom has no charge, it is neutral. But electrons can move from one atom to another. Some atoms get extra electrons. They have a negative charge. Other atoms lose electrons. They have a positive charge. When charges are separated like this, it is called static electricity. Static electricity is the imbalance of positive and negative charges. If two things have different charges, they attract each other. If two things have the same charge, they repel each other. Charged objects can create an invisible electric force field around themselves. The strength of this field depends on many things, including the amount of charge, distance involved, and shape of the objects. This can become very complicated. We can simplify things by working with point sources of charge. Point sources are charged objects which are much, much smaller than the distance between them. Charles Coulomb first described electric field strengths in the 1780s. He found that for point charges, the electrical force varies directly with the product of the charges. In other words, the greater the charges, the stronger the field, and the field varies inversely with the square of the distance between the charges. This means that the greater the distance, the weaker the force becomes. This can be written as the formula. Current electricity. The word electricity is from the New Latin electricus, amber-like, coined in the year 1600 from the Greek meaning amber, because electrical effects were produced classically by rubbing amber. Alessandro Volta discovered current, electricity and voltage. The unit for current is ampere, shortened to amps, and was discovered by André Marie Ampère in 1820. Resistance is the restriction of electricity flowing through a conductor. Resistance also causes heat. It is measured in ohms. The symbol is Greek omega and can be worked out with Ohm's law. Volts equals current times resistance. The discoverer was George Simon Ohm, a German physicist and mathematician. Electromagnetism. It is the effect of the electromagnetic force, which is one of the 4 fundamental forces in the universe. Electromagnetism is the relationship between magnetic fields and moving electric fields. Electromagnetism is the force that causes the interaction between electrically charged particles and is responsible for practically all the phenomena observed in daily life, except gravity. Electricity and magnetism are 2 obvious examples. The chemical bonds holding molecules together are electromagnetic. Light is electromagnetic radiation. The light need not be visible light. Heat, infrared radiation, ultraviolet radiation, gamma rays, microwaves, radio waves. All of these are examples of light.